Buffer solution are water solution that keeps the hydrogen index value in two situations: when they diluted with water, or when a small amount of acid or base is added into solution. Once again, buffer solution or system are water solutions that keeps the hydrogen index value in two situations. At first, when they are diluted with water, or when small amount of strong acid or base is added into solution. Buffer system are divided into types. First is acidic buffer solution or system. They composed from weak organic or inorganic acids and their salts. For example, acetic or hydrocarbonate buffer system are acidic buffer system. The second type of buffer solution is basic. It consists of from weak base, for example, ammonium hydroxide, and its salt. Theory that help to us to understand how does buffer system work was formulated by two American chemists, Bronsted and Lowry. That's why we discuss some questions from the theory. According to theory, all chemical reaction is transfer of proton from acid to base. I'm sorry. Acid is particle that can give away proton. So, according to proton theory, any chemical reaction is transfer proton from acid to base. Acid is particle, it may be ion or molecule that can give away proton. For example, hydrochloric acid during dissociation form one proton and chloride ion. That's why hydrochloric acid is acid. Base is particle, ion or molecule that can add proton. Particles that can as give away as add protons are amphibolite. Particle that can give away and add protons are ampholyte. For example, water is ampholyte due to it can give away protons, and as a result hydroxide ion will form, and it can also add protons, and as a result hydroxonium ion will form. From organic compounds, amino acids and proteins are ampholytes. So let's discuss composition and mechanism action some inorganic buffer system and try to describe the mechanism according to proton theory. Acetate buffer system is composed from weak acetic acid and sodium acetate. Acetic acid as weak acid is donor for proton because during dissociation it forms protons. Sodium acetate is strong electrolyte, so it will form acetate ion that can add proton, and as a result acetic acid will form again. That's why sodium acetate is acceptor for proton. Mechanism of buffer action is interaction of donor or acceptor with some component that will add it into buffer solution. For example, when some strong acid, for example hydrochloric acid, will add it into buffer solution, it will interact with acceptor for protons at buffer system composition, and as a result weak electrolyte will form. Interaction between acceptor from buffer solution and strong acid may be expressed by molecular equation and short ionic equation. Short ionic equation shows interaction between particles that are represented at solution. So strong inorganic acid is donor for proton, and sodium acetate from buffer solution is acceptor for proton. When any strong base will add it will react with particle that is donor for proton. Strong base is acceptor for proton because during dissociation it forms particle that can add proton. It is hydroxide ion. That's why it will interact with particle that is donor for proton. As a result, weak electrolyte will form. Mechanism of interaction may be represented by molecular or ionic equation. So it is example of acidic buffer system. Now let's discuss composition and mechanism action for basic buffer system. The most common example of basic buffer system is ammonia buffer solution. It represented by weak base, hydroxide ammonia, and their salt, for example, ammonia chloride. Weak base will acceptor for proton, and its salt will donor for proton. So when any strong acid will be added to ammonia buffer solution, it will interact with acceptor for proton, and as a result, water, weak dissociated compound will form. It may be represented in molecular or ionic equation. For the credit test, you must represent mechanism action not in molecular but in ionic equation 2. When some strong base will be added into buffer solution, it will interact with donor for proton, and as a result, weak base will form again. So let's write down intermediate conclusion. Why does buffer solution can keep the hydroxide index value. So the first position is components of buffer solution form pair donor and acceptor for proton. Components of buffer solutions form pair donor and acceptor for protons. This is second position. Excessive amount of hydrogen ions or hydroxide ions connects with acceptor or donor for proton from buffer system. Excessive amount of protons or hydroxide ion that are added into buffer solution connect with donor or acceptor for proton from buffer system components. And as a result, weak electrolyte or water forms. So it's very easy to remember. So if we add acid, it will connect with acceptor from buffer solution. If we add base, it will connect with donor for proton from buffer solution. So at practice, buffer solution are used for different research of biochemical reaction. That's why we must know how does buffer solution prepared, and we must know how does hydroxide index value for buffer system is calculated. Hydroxide index value for buffer solution is calculated according to Henderson-Hasselbalch equation. It will have different expression for acidic and for basic buffer solution. Its expression will depend on the type of buffer solution that you will prepare. So pK is index of acidity, and pKb is index of basicity. When you will discuss together with your teacher theory of dissociation, you will know what does it mean acidity constant and basic constant. And then you will calculate different pH values for different buffer system. So buffer system will keep the hydroxide index value until donor or acceptor for proton will represented inside it. Buffer solution or buffer system will keep the hydroxide index value until donor or acceptor for proton will represented in it. When donor or acceptor for proton in buffer solution will involve in interaction, when all donors and acceptor for protons will involve in interaction, hydroxide index for buffer system becomes change. That's why we use term buffer capacity. So buffer capacity is amount of strong base or acid in mole that is required to be added in 1 liter of buffer solution for change hydroxide index value at 1 unit. So buffer capacity is an amount of strong base or acid in mole that is required to be added at 1 liter of buffer solution for change hydroxide index value at 1 unit. There are two measures of buffer capacity. The first is acidic buffer capacity. It is signed as Ba. And the second expression is basic buffer capacity, Bb. They calculated according the same formula. They are calculated according the same formula. There are multiplication between concentration and volume of strong electrolyte in numerator and multiplication between volume of buffer system and change at pH unit in denominator. Change at pH unit must be taken at model. Buffer capacity is expressed in mole per liter. C mean molarity of strong electrolyte. Volume can be expressed as in liter, but is more comfortable to express volume in milliliter. Now let's discuss biological signification of buffer system and discuss composition and mechanism action, the most important buffer system in our organism. So hydroxide index or pH is most important measure for our organism because hydroxide index value impact impacts on enzymes activity, and it is impact on biochemical reaction rates. Change in pH at biological liquid may be diagnostic sign for different disorders. For example, when some patient has decrease at pH value for blood, it means that different acids accumulate at biological liquid. And it may be sign of diabetes mellitus. Or, for example, when some patients has increase in pH value of urine, it means that there is disorders of kidney function develop. Or it may be diagnostic sign for disorders in microelements exchange inside the cell and tissue. So we must know how does our organism keeps the hydroxide index value. How does it keep the acid and base equilibrium as one of sign for homeostasis? The most important buffer solution in our organism is blood. It plays different roles, but the general is transport rule. Blood transport different nutrients inside cells and tissues and transport final metabolites from tissues and cells. Blood is represented by plasma that contains different minerals and water and formed elements. Leukocytes, they are leukocytes, red blood cells, thrombocyte, and others. There are several buffer systems that act at blood. There are several buffer systems that act in blood. In general, they are divided into buffer system of plasma and buffer systems of red blood cells or erythrocytes. At plasma, the most important buffer system is hydrocarbonate. In erythrocytes, the most important buffer system is hemoglobin. Phosphate and protein buffer system are represented as in plasma as in erythrocytes. So for control test, you must know composition and mechanism action for all these buffer system. So let's begin from the most important buffer system, hydrocarbonate. Hydrocarbonate hydrocarbonate buffer system is represented by weak inorganic carbonic acid and their salt. So hydrocarbonate buffer system is represented by weak inorganic carbonic acid, and their salt, sodium hydrocarbonate. Carbonic acid forms when carbon oxide 4 dissolves in water that contains inside cells under enzyme carbon anhydrase action. Carbonic acid will play donor for proton role, and sodium hydrocarbonate will acceptor. So when excessive for protons will appear, they will neutralized by acceptor for proton, and as a result, weak electrolyte will form. The second mechanism is about excessive of hydroxide ions. So when excessive in hydroxide ions will appear in biological liquid, they will neutralized by donor for protons, and as a result, water will form. So, of course, inside our organism, nitric or hydrochloric acid will not appear. Change in pH or excessive of hydroxide or hydrogen ion may be caused by excessive of organic acid, for example, citric, lactic, or another organic acid. They can lead change at pH in blood. The next buffer system that play important role is phosphate buffer system. Phosphate buffer system is acidic buffer system too, but it includes not phosphorus acid but their salt. It happens because phosphorus acid is electrolyte with middle forces, and as we know, only weak acid can be involved in composition of buffer system. Phosphate buffer system acts as in blood plasma as in erythrocytes. It is represented by sodium dihydrophosphate and sodium hydrophosphate in plasma, and potassium dihydrophosphate and potassium hydrophosphate in red blood cell. So please remember that when you will describe composition of phosphate buffer system in plasma, concentration of sodium is higher compared to potassium. And if you will describe composition for cell, remember that inside cell, concentration of potassium is higher compared to sodium. At slide, composition for phosphate buffer system of plasma is represented. Sodium dihydrophosphate is donor for proton, and sodium hydrophosphate is acceptor for proton. So sodium hydrophosphate will involve in interaction when some strong acid will added into buffer system, or when concentration of organic or inorganic acid will increase in blood. Mechanism action may be represented by molecular and ionic equation. And as a result, another component, dihydrophosphate, forms after reaction.